everyone. Once again, good day. This is Professor Roger Flores, your professor of the subject EE30, Electrical Engineering Utilities. So for today, we are going to continue our discussion with regards to our subject, and let's proceed to Chapter 3. This is entitled Building Electrical Design Principles. Okay, so here we're going to discuss some of the important thing with regards to electrical design. So to start with, we have this chapter 3, building electrical design principles, and we have here the first subtopic, electrical codes, licenses, and permits. So here, when we discuss electrical codes, we are going to discuss some or little things about the Philippine Electrical Codes, or the Philippine Electrical Code, or PEC, no? And then we have to also, I will give you some important thing when it comes to licenses, the license of the electrical practitioners, and for the permits, no? So permits in applying for this in the construction or the installation of the electrical installation. Okay, so when it comes to electrical codes, we have this Philippine Electrical Code, no, in which this electrical code specifies the written provisions necessary for protecting people and property from the improper use of electricity and electrical equipment. So basically, this electrical code is just to protect for the safety of our property, property, and most importantly, to protect the end user or the people that is using this electricity. Okay, so let's start with this National Electrical Code. This is the worldwide code for the electrical services. No? So the NEC, or the National Electrical Code, is a set of specifications and standards in the form of a model code that can be adapted into local law by the local government entities. So we have this NEC, no, or National Electrical Code. The NEC was established in 1887 through the combined efforts of insurance, electrical, architectural, and other interested groups. In 1911, the National Fire Protection Association, or NFPA, became the sponsor of this National Electrical Code and continues to act in this capacity. Okay, so that is the short information about the National Electrical Code and the National Fire Protection Association. Okay, so let's specifically discuss the Philippine Electrical Code. By the way, the Philippine Electrical Code that we are going to discuss here is the revised 2017, no? The latest electrical code of the Philippines. Okay, so we have this for the general provisions. So the purpose of this Philippine Electrical Code, it is for practical safeguarding of persons and property from hazards arising from the use of this electricity. So practical safeguarding, yun na po yung sinabi ko po kanina. Then when it comes to adequacy, because this Philippine Electrical Code contains provisions that are considered minimum requirements necessary for safety. So this is adequate for the safety, minimum requirements for the safety of the end user of this electricity. And then we have this FPN, no? So we have this FPN. So we have FPN number 1. Hazards often occur because of overloading of wiring systems by methods or usage not in conformity with this code. Okay, so this is an idea about hazard usage of this electricity, no? Maybe overloading of wiring system. So na-overload po yung capacity ng ating mga wires or conductors. Then or usage of this electricity not in the conformance in this Philippine Electrical Code. This FPN number 2, it is highly recommended that a licensed electrical practitioner be consulted for any electrical requirements, okay, including changes, of course, revision. So, licensed electrician, licensed electrical engineer, professional electrical engineer, registered electrical engineer. Okay, when we say license, then it should be updated or renewed license, no? Because otherwise, if the license is expired, it seems that the same thing with that practitioner has no authority and has no license, no? Kung hindi po yun na-renew yung lisensya niya. For this FPN number 3, fire hazards, electrocution, serious injury, or even death, no? May also occur with lack of improper maintenance of wiring system. So we have this FPN number 3. So hazardous electrocution or hazard electrocution or even serious injury, fall or yung nahuhulog, or even that will results to death, may also results or occur due to this improper maintenance of wiring system. Intended as a design specification or an instruction manual to qualified person. So of course, our Philippine Electrical Code is for the use of the design specification, which will be maybe specified by these qualified persons. So again, these qualified persons are those electrical practitioners having a license. Okay, so relations to other international standards. So we have this like NIC, no? We have that international standards, and this Philippine Electrical Code, okay, address the fundamental principles of protection for safety contained in Section 131 of the IEEC, no? Or the International Electrical Code 60364-1, or we call this one as electrical installation of this building. Okay, so we have this FPN of 131. They said that encompasses protection against thermal effects, no? Thermal effects, protection against overcurrent, and protection against fault currents, and protection against over voltage. So we have this FPN section 131, no? So this encompasses, or this covers the protection against thermal effects, yung umiinit yung devices natin, or your conductors natin, or even protection against overcurrent, so mubra yung load natin, so tumaas yung kuryente, or fault currents, yung mga short circuits and other fault currents, no? So yun pong mga tinatawag na fault currents. Short circuit, so we have several type of short circuits. You have the series, you have the parallel, or you have the simultaneous faults, no? So we have these types of faults. Then we have the protection against over voltage also. So we have that one. So we have this scope of this Philippine Electrical Code, no? This covers the installation of electrical conductors, equipment, the conductors, RC conductors, you have the wire, the cable, and the equipment, and raceways. Raceway is used to protect our conductor, the insulation. So meron tayong tinatawag dito na tubing or raceway, no? Signaling and communicating conductors. So when we say signaling, this is basically used for sensors, for maybe fire, no? Fire suppressant or fire suppression, control and protection. And then the communication system, cables, cabling in the internet or any internet connections or cabled and networking. Okay, so it does not cover the installation in railway rolling stock, aircraft or automotive vehicles, installation of railways for generation, transmission, transformation or distribution of power used. So, hindi po ito nag-cover ng mga railway, rolling stock or kahit yung sa mga moving, no, mga ano ba yan, mga yung sa aircraft or automotive vehicles, no. So, hindi kasama dito yung sa mga sasakyan or even in the railway or yung sa mga train, no. So, even installation of railways for generation, transformation, and transmission of or distribution of power used. Okay, so we have this authority. Saan po ba nakuha yung authority natin? Sa Philippine Electrical Code. It has been approved and adopted by the Board of Electrical Engineering and the Professional Regulation Commission. And also, its authority is vested on the in the board under the Philippine Electrical Engineering Board, okay, under RA 7920 or known as the New Electrical Engineering Law, okay, Republic Act 7920. Okay, so these provisions of the Philippine Electrical Code has been given authority by this Republic Act 7920 and which this code also is approved or was approved by the Board of Electrical Engineering in the Philippines and the Professional Regulation Commission. For the enforcement of this code, it was given to the Office of the Building Official or the Electrical Engineering or over electrical installations. So yung enforcement of this code is through the building officials of the municipal or city engineering office or through their electrical office or personnel. Okay, the Office of the Building Official shall have the responsibility of implementing the provision of this code and require new products, constructions, materials that may yet be available at the time of this code adopted. So, we have this authority or enforcement kung sino po yung authorized to implement this code if we have that we may require new products, construction, materials, and any other related to electrical engineering or electrical installation. So it is, we have these mandatory roles, permissive and explanatory material and appendices. Ano po ba itong mga mandatory rules and permissive? Ano ba ibig sabihin nito? So when we say mandatory, are those that identify action or actions that are specifically required or prohibited and are characterized by the use of this term, shall or shall not. So when we say mandatory, if you have provisions in this Philippine Electrical Code and it is said it mentioned shall, then it is mandatory. Or if it is shall not, then of course it is also mandatory pero hindi dapat gagawin. Okay. So when we say permissive, these identify actions that are allowed by not required, are normally allowed but not required, are normally used to describe options or alternative methods. No? So we have that optional or alternative methods. If you are going to, if it is permissive, then okay, that some of these provisions in the this Philippine Electrical Code may apply. Okay? So, mayroon pa isa dito, explanatory material. Ano pa ba itong explanatory material? Okay, so this refers to the references to other standards, references to related section of this code, and others, no? Or ito pong tinatawag natin kayo na FPN. Ito po yung fine print notes o sa iba pa nga dito, tinatawag natin ito ng mga footnotes, no? So ito po yung mga importanteng mga notes na kailangan natin malaman and summarize below, no? So mayroon tayong tinatawag na FPN number or fine print notes number. Okay, so mayroon din tayong tinatawag na appendices, no? This is not a part of the enforceable materials or requirements of the Philippine Electrical Code but are included for information purposes only. Okay, so yun po, doon yan makikita sa mga appendices. Okay, so let's continue to manufacturing standards. Okay, so ano po ba itong mga manufacturing mga standards, mga ibang standards dito? So mayroon tayong tinatawag ito nga, all electrical equipment, applications, devices should not specific safety standard should meet, not should not. Okay, devices should meet specific safety standards based on regular product testing and approve product meets minimum safety standards as determined by extensive testing by an independent testing company or organization. So, ito po yung tinatawag natin na manufacturing standard, that it should be approved product, no? So, kaya dito sa Pilipinas, mayroon tayong tinatawag na PS. Mayroon tayong sale na PS or ibig sabihin product standard. Ito meaning to say that this material pass through some safety testing or test, no, by any other independent testing company or organization. Okay, so we have this Underwriters Laboratory Incorporated, or you might see this UL. So, minsan mayroon tayong makikitang mga materials or produkto na mayroong tatak UL. Ito po yung sinasabi nating Underwriters Laboratory Incorporated. It is a not-for-profit product safety testing and certification organization. Is also the leading third-party certification organization in the United States, no? And has been evaluation products in the interest of the public safety since 1894. Okay, so we have also this National Electrical Manufacturing Association. So this is NEMA, no? So by the way, class, if you are going to specify standards, no, for any material, electrical material, so try to specify this NEMA compliance, no? So ano po itong NEMA compliance? Of course, this is one of the leading trade association testing in US, no, representing the interest of electrical manufacturing. NEMA is NEMA's member companies manufactured products are used in the generation, transmission, and distribution control and end use of electricity. Mayroon po naman po tayong tinatawag na Council for Harmonization of Electrotechnical Standards of the Nations of the Americas, no? So ito po yung tinatawag nila na kanina. Okay, so ito this is one also of the company that will test our product for performance and the usability of this product. Okay, next let us discuss licensing, no? Most of the municipalities have local laws that require that any person who wishes to engage in the business of installing electrical systems must be licensed, no? Here in the Philippines, we required through our municipal and city engineering office, we required that all other practices of these electrical installations or electrical practice, it should be done by the licensed practitioner, no? So this means that the person must have a minimum number of years of experience with a licensed electrician and must pass a written test that deals with the electrical code being used with methods of installations. So that is why all electrical engineers must have to pass the board examination given by the Philippine Electrical Engineering Board, no, through the PRC or Professional Regulation Commission. So we have to take so that this examination or this board exam, so that we will be permitted to practice electrical profession. Okay, by requiring a license, it is assured that the electrician knows at a minimum the code requirements and installation procedures. Okay. So we have also these permits. No? Most municipalities require that a permit be issued before any electrical installation may be made on a project. So it is very clear no, that before you are going to install any electrical devices, equipments, you must have to ask first permit from the municipality or in the city. Okay, a complete electrical construction drawing may also be required for review and approval by a plans examiner before installation begins. Okay, then this office also will require, or that require a permit will have electrical inspectors. Okay, so we must have these inspectors who check the project during regularly scheduled visits. Okay, so you have this inspector to check whether or not this installation or the contractors follow or comply the requirements of the basic requirements of the electrical installation. Okay, so these inspectors will inspect the installation after the rough writing is in, but before it is concealed behind construction materials. Okay. Then next we have this electrical construction drawings. Ano po ba itong mga construction drawings? No? So unang-una, an electrical construction drawing shall or shows the layout and design of an electrical installation. So yun po, yung mga drawing natin will help us or will help the electrician in the installation, because the drawing will be the basis of the installation, and it must be first approved by the municipal or city government through their electrical department or through their engineering office. No? In order to convey the desired design information to the contractor, it is a must to obtain complete set of construction drawings and specifications of the building electrical system. Okay, so it's very clear that complete set of construction drawings and specifications before this installation of electrical system will commence. Okay. So, the following construction drawings and details are generally required. Unang-una, complete plans and specification of all electrical works. Pangalawa, we have labeling criteria of all electrical equipment. Then next, lighting floor plans including electrical circuit indicating conduit and wire sizes. Okay, so floor plan, kailangan po natin ito, which will include the electrical circuit, which indicates conduit or any tubing or raceways and others, no, to protect our insulation of our wire, and also it includes also wire sizes. Okay, so the fourth one, power floor plans including electrical circuits indicating conduit and wiring sizes, no, equipment and disconnected switches. Okay, so exit sign, means of egress, lighting, location, and power supply. So we need to indicate also the signages, especially for entrance, exit, fire exit, comfort rooms, and any other stairs, elevators, so on and so forth. No, so any other signages. So we have to find or locate. Okay. So we have also some other egress, lighting, location, and power supply, kung saan po nakalagay yung power supply natin. And it will also indicate panel board schedule. Okay, number 7, lighting fixture schedule, or that tinatawag natin po itong schedule of loads, no? So we have the symbol schedule diagrams. Okay. What else? So, by the way, specifications and drawings should be included requirements here. No, they have the raceway and conduit, of course, with fittings, wire and cables, electrical boxes, so fittings and installation. We have this, when we talk about boxes, we have this utility box, and we have this junction box, and or even pull box, no? Fitting for installations. Number 4, electrical connections, electrical wiring devices, circuit and motor disconnects and protection, no? Disconnecting means. Okay, hangers and supporting devices. Okay, especially if our installation is in the ceiling, so we need to have a supporting equipments or devices or design. Okay, so hanger, no? So that it is not directly stapled or fixed in the ceiling joist or in the installation, no? So electrical identification. So this is necessary so that we will be able to identify which is the hot or the live wire, which is the ground wire, which is the neutral wire, no? So service entrance and details. So the service entrance cup, the receiving part of the installation from the electrical pole of the distribution utility towards our building. Okay, so service entrance and details is very important. Number 10, we have overcurrent protection. So actually, we have these two types of OCP, overcurrent protection devices. We have the overcurrent protection, which is the fuses and the circuit breakers, no? So switchboards. Okay, this is a cabinet that includes protection all over the circuit. Now we have that switchboards. And also it includes also specify also the grounding system in the building. So this is very important. Grounding system is very important. Okay, so this is to protect the whole installation. Then we have the transformers. We know in our previous discussion that transformer is used to step up the voltage, to step up the current, or to step down, or to step down the voltage and the current, so on and so forth. But take note that when you're going to step up the voltage or the current, the power of the system remain constant, no? So we have also these panel boards, and we have to specify also and the drawings of the motor control centers if you are motor loads. So we have these symbols are specifically used in construction drawings to represent lighting and power, and the power distribution components and equipment. So we have to determine the symbols in the plan. Okay. Okay, so talking about symbols, predominantly there is no specific symbol accordingly. Okay, and but there is a universal accepted symbols also by the industry, and this symbol, okay, that will be shown in the next slide, typically modified by the engineers, no, and consulting firm used in their drawings. So we have these symbols that is basically commonly used in the drawings. But of course, if the device is not there in the suggested symbol, then you should have to create your own symbols and see to it that it is finally defined in the symbols and legend. Okay, so these are some. I hope that you can still read this one. These are some of the abbreviations and acronyms of the things that we use in the electrical design. Okay, so we have these electrical symbols, no? Mayroon po dito una yung mga switches. Mayroon po dito yung mga receptacle outlets, no? Mayroon din po dito mga lighting outlets. So marami, no? So these are some of the devices that we use with their specified or respective symbols. So sabi ko nga kanina, if the device that you're going to connect in the system is not, their symbol is not available, or its symbol is not available, then try to use your own symbol and then try to label it in the legend and symbols. Okay, symbols are well arranged on the drawing in the form of one line diagram. Okay, so we have this one line represents the conductors extending between two symbols regardless of the number of conductors. Generally, the single line without any additional identification indicates a two-wire set of conductors, either on ungrounded hot and grounded conductors, or two ungrounded conductors. This was just a suggestion. Okay, so ito po yung example, no, ng single line, okay, without any additional identification. Okay, so we have this example. So yung unang-una natin dito, we have the source. Okay, we have this ground point. By the way, this is 120. Here in the Philippines, we are using 230, no? So we have this neutral, and this is the live, because this is line to ground, no? So you have this line here. Okay, so we have our load, no? No voltage between case and ground. So situate that no voltage, there should be no voltage between the system or this casing of our load and the ground. So para walang short circuit na mangyayari. Okay? So a single line with three slashes indicates a three-wire set of conductors and so on. So usually ang symbol po yung ginagamit natin sa single phase or three-phase. Lagyan lang natin ng slash or diagonal line to indicate the number of connection or number of wires. Okay, so we have this one, no? So meron tayong, ibig sabihin dito, this is a three-phase. We have three conductors. Okay, that's a simple symbol. Then next, we have building system voltages. So it is said that supply voltage, which is expressed in nominal voltage, because varies slightly only. Okay, and this is the or it will vary from 90 to 105% of the nominal voltage under normal conditions. No, variations from nominal voltages are caused by a number of reasons, including variation in a load and changes in condition in the power systems. So it's very clear. Now we have this medium and high voltage system can carry voltages about 600 volts, and it may be used in special case such for the large signages. Okay, so low voltage system that carry voltages less than 600, and of course typically used in buildings. So system voltage is expressed as nominal voltage because it varies slightly for the reasons of mentioned earlier. So we have this circuit wiring. So unground hot conductor. So mayroon po tayo dito. Okay, is the initial current carrying conductor in an AC system. The ungrounded conductor is frequently known as the hot or live conductor because it feeds current to the circuit. So grounded neutral conductor is required to complete a single phase circuit by connecting the ungrounded conductor to ground. Okay, the neutral conductor is a grounded conductor that serves more than one circuit. So maroon po tayo niyan. And then a third conductor that provides grounding conductor, supplementary but important grounding protection. The grounding conductor is not normally a current carrying conductor, but energized only on a temporary emergency basis when there is a fault between an ungrounded hot conductor and to any metal, no, associated with the electrical equipment. Okay, so we have this common building systems voltages. So as you can see here, 120 to 40. But take note that we are not using 120 here except for specialized outlet, no? So yung ginagamit po natin dito is 230 or 300 or 400 or 240 or 480 volts, no? So we have this alternating current single phase to wire system, the most basic system voltage, no, used in the electrical circuit. It was used in the first electrical services building. However, nearly all have since been upgraded, no? So we have this information. So this is the most common residential electrical service in use today. Okay, so try to refer your discussion with this single or three wire, in which the other wire is your neutral. Okay, ibig sabihin na neutral, wala po yung potential, walang voltahe. So small office buildings, churches, and retail shops and stores. On a 120-240 system, a 120 volt branch circuit provides electrical energy to conveyance outlet, small appliance, and light appliance. So we have this, no? We have this common voltage, no? Okay, so this is for alternating current, three-phase, pure wire, four-wire system. Okay, so meron po tayo dito. Ang pangatlong ano po dito is yung normal or your grounding system. Okay, so an older electrical service found in small commercial buildings. Okay, so we have this another voltage, 480 Y to 277 volt amperes. Okay, so 600 Y, 346 volt recording current, and the four-wire systems, no? So just go over with this one. This is also we should have to know this one, no? The relationship between the building system voltage, current, and required conductor size for 20 kilovolt ampere. Okay, so we have this one, no? Minimum, no, requirement. What is system voltage? It is the target voltage entering the service panel. Okay, so system voltage will vary in slightly for different buildings because of variations of voltage available at the transformer and voltage drop in the service conductors. That the standard for the system voltage is 120 or 230 volts. Okay. We have also this utilization voltage. The voltage drop occurs as current flows from the service equipment through the branch circuit conductors to the outlet. Maximum voltage. Okay. Wiring device such as switches, receptacles, relays, and conductors are designed to ensure voltage slightly higher than the utilization voltage. The highest voltage to which a wiring basic can be exposed as known as maximum voltage. Okay, so we have to understand that when we say maximum voltage, yun po ang pinakataas na voltahe sa system. Otherwise, pag madagdagan pa yan, then of course, it will damage our system, no? Kasi masyado nang malaki ang ating mga voltahe. Okay, so 3.4. This is all about grounded and ungrounded conductors. So let's proceed to 3.4, grounded and ungrounded conductors. Okay. So we have here some of the content: grounded conductor, neutral conductor, okay, sorry, and the load balancing. Okay, so here we are going to discuss this one by one. What is the difference between grounding or grounded conductor and neutral? And of course, this load balancing. So what is grounded conductor? Basically, according to the definition, a grounded conductor is defined as the system or circuit product that is intentionally grounded. When something is grounded in accordance with the National Electrical Code, it's connected to ground or to a conductive body that extends the ground connection. Okay, so in a single branch circuit, the grounded conductor serves as the grounded leg of the circuit. It completes the circuit by connecting the ungrounded conductor to wire. Thus, in circuit design, Okay, the grounded conductor is considered to be current carrying conductor because it serves as a return path back to the circuit's power house. Okay, so I hope that you had been practicing this one. Grounded conductors are meant to keep people from getting shocked when using electrical services or appliances. It keeps the metal of the outlet from the getting hot and causing electrical shocks. Okay. So what is a neutral conductor? This neutral conductor is forms the function of a grounded conductor for at least two ungrounded. Okay, so at least two ungrounded conductors. Then you're going to connect this to the ground or to the to land, no? So we have this okay, so we have this ungrounded hot conductors that have sources from the different voltage spaces, such as multi-wire branch circuit, multi-wired feeder, and the electrical service if it is grounded conductor. Okay, so thus neutral conductor is frequently called shared neutral or common neutral. So we have that name. So we have this example, no? The natural load on a 120 or 243 wire feeder circuit carries an unbalanced load in the ungrounded conductors of 60 amperes on phase A and 58 amperes on phase B. So determine the grounded neutral conductor load. So unbalanced load, determine this one. We have the full load, okay, ungrounded full load of 68 amperes. And the grounded full load of 58 amperes, no? So we have this 10 ampere difference. Okay, so yun po, wag tayong magkumpiyansa kasi po yung 10 amperes ay masyadong malakas na yan for our body to resist this to resist the overcurrent, no? So unbalanced load means the results of subtracting the full load and the no load, the 68 amperes. So we have here, okay, so ungrounded, and then we have this minus 58 amperes, no? So for phase A and phase B respectively. So what you're going to do to determine the unbalanced load, we have to subtract 68 by 50, and we have this or 58 we have here already 1 or 10 amperes. So the grounded neutral conductors used is 10 ampere for this condition. Next, we have these ungrounded conductors. So, and it is called also as hot wire because it is not grounded. So this is a live or hot wire. Although both the grounded and ungrounded conductors connect to the earth, if an accident occurs like an appliance breaking, you can get electrocuted if you come into contact with an ungrounded conductor. So just careful of these ungrounded conductors. Okay? So we have also this load balancing. Ano po ba itong tinatawag natin na load balancing? So load balancing in the practice of dividing loads as evenly as possible between the ungrounded conductors on a multi-wire circuit feeder. Meaning to say that this load balancing is trying to balance our system. Okay, sana mabalance natin yan para walang kuryente na lalabas doon or the neutral path, no? So para hindi tayo ma-electrocute. So we have that. A well-designed neutral is balanced to that so that under load little or no current flows through the neutral conductor. On a multi-wire circuit, each underground conductor should carry loads equally. Okay? So we have this in a 120, 240 single phase 3-wire conductor. If one ungrounded conductor feeds a 16 ampere, then load on one circuit and the other feeds a 4 amperes load in the other on the other circuit. The common neutral conductor carries 12 amperes to ground. This is the difference between the two loads. Okay? So, yan po. Number 3.5, we have this system and circuit grounding. So, when we say grounding, this offers excess electricity, the most effective and safest route from an appliance back to the ground by way of electrical panel. So that is the grounding system. Electrical grounding is a backup pathway that is generally only used in the fault ano yung tinatawag natin dito? Used if a fault in the wiring. Okay, so we have this. So grounding conductor, it is a continuous conductor that connects the ground to the neutral bus bar and the grouping conductor bus bar in the service of equipment. So we have also this grounding conductors uses, no? So a safety daily or carry current to carrying or it safely carry current to ground in the event of lighting site in case of damage or the damage or defect in the circuiting appliance services or equipment, no? It also provides safety feature in the wiring system. Okay, so we have to continue. So we have here two types of grounding requirements. Nawala na dito iba kasi hindi to ano. Anyway, two types of grounding requirements. Unang-una po, system grounding. Pangalawa, equipment grounding. And of course, we have the auxiliary requirement. We have the binding here. So we have two types of grounding requirements. Okay, so we have these two types of grounding requirements. Equipment grounding conductor is a bare conductor or a green-colored insulated conductor that connects bands, the outlet boxes, metallic raceways, other insulations, and enclosures and frames and motors, appliances, other electrical equipments. So, double insulation of an appliance or power tool protects the user from electric shock by creating a non-conducting barrier between the user and the electric components inside the appliances. So, diyan po natin makikita na it's very important to have this double installation or insulation. Small appliance and power tools with double insulation are not required to have a grounding conductor. That is, they are allowed to have a two-prong plug. Okay, so we will para medyo madagdagan pa natin ang explanation mamaya. The primary differences or difference between an appliance with a three-prong plug and an appliance with a two-prong plug is the appliance casing. Yun ang pong casing niya, no, sa appliances. If an appliance casing is a good conductor, then we will made up of having this metal. Then it must have the grounding conductor and three-prong plug. Okay. So next, let's proceed to the building electrical system. 3.6 here. So here we're going to discuss some important thing in the electrical system, and some of information are just were already discussed in the previous chapter. Okay. So building electrical system, what is this all about? There are many possible electrical systems that can be used to distribute power in a building. Typically, system design begins with the selection of the building system voltage. So, ano po ba yung available natin system voltage para yun ang magagamit natin sa design? Which is dependent on the sizes and types of the connected loads, utilities near the building, local codes and ordinances, economics and safety. So, try to consider that. We have the subtopics: residential systems, multi-family dwellings, commercial or industrial systems. So let's talk first about residential system. This means a ground-mounted or rooftop distributed solar generation system is designed and installed for residential applications, which is leased by or subject to a power purchase agreement with the power of the residents for the purpose of generating electricity for that residences. Okay, so kita nyo, this is just an example of the residential wiring or connection. So makikita nyo dito, we have these panel boards, we have the meter and others, no? You have this pole box or junction box, and the rest of the distribution of the load. Okay, so multi-family dwelling. Okay, so let's talk with this multi-family dwelling. It is a single building that's set up to accommodate more than one family living separately, that can range from a duplex, which has two dwellings, no, within a single building, to homes or small apartment buildings with up to 4 units. Okay, so that's very clear. When we see a multi-family dwelling, this is a single building, one building, which shared for shared accommodation for several family. But of course, separate po itong isa't isa, no? So mayroon po siyang separate na control, mayroon po siyang separate na protection, mayroon po siyang separate na mga metrohan and others, no? So that is a multi-family dwelling. So ayun, apartment or duplex house and so on, no? So we multi-family dwelling units, power is brought from a utility transformer to the building service equipment. It is then divided. Okay, it is then divided at the main distribution panel, passes through individual meters, no, and is distributed to the individual dwelling units through feeders. Okay, so that's very clear that we have these things that you're going to consider if you are talking about multi-family dwelling. Okay, example to this multi-family dwelling, this is a sort of apartment. Okay, a single building used to apartment, or a single building like this one. This is a condominium, no? This is a condominium, or this is a single apartment type, or we have this one. So ito po yung tinatawag natin na multi-family dwelling. Okay, so commercial industrial systems. Okay, so this is a large commercial industrial facilities have large and varied power requirements that necessitate different types of systems for different building occupancies. Okay, so ito po yung mga underground mga entrances natin, no? Underground electrical distribution, where lines serving this residential building being buried in a trench. So ito, or underground distribution lines related that for connection to exterior transformer. So we have this electrical meter. We have the electrical meter for family dwelling, and we have this electrical meter main disconnect. Okay, so we have that one. Panel board. Okay, we have this, no? Ito po yung panel board natin. According to our definition last time, that the panel board is where the protection can be found, your circuit breaker, the others, no? Disconnecting means. So circuit cables, of course, that is the that will pass through the ceiling joist. Okay, and this exposed lighting fixture. Okay, so we have all these things here. So exposed box is a finished drywall. We have also the receptacle and faceplate. Okay, so your receptacle should have a cover, no? Itong tinatawag natin na faceplate, para hindi diretso na mapaglaruan ng mga anak natin. So we should have to consider this faceplate, no? So covered convenience receptacle. Okay, so mayroon po nga tayo dito, covered convenience receptacle. Okay, I hope that you learned many things in our discussion, especially on how you're going to design some of the important thing with regards to the installation and our households, no? Okay, so once again, thank you for listening. God bless. Thank you very much.